So in this video, we're going to go back to our favorite topic of factoring polynomials. Now we've looked at factoring quadratics. We have ways to do that. If it's a quadratic, if all else fails, you can go into the quadratic formula, right? You can find the zeros. With the zeros, you can find the factors. We've looked at factoring higher order polynomials when you can easily factor out a common factor and get it into a quadratic that we can use the quadratic formula or factor with our box model or whatever is your favorite, unfoiling, whatever you want to say that. We're going to look today at how you can use division to help factor a higher order polynomial. So like this one, we want to do x to the fourth plus 2x cubed minus 7x squared minus 20x minus 12. And I'll go back to, grade school. Go back to when you're first learning about factoring. And we said factor 732. And say, well, what number could go into 732? This would be, and you'd say, well, it's even, 2 must go into it. Well, what's the other factor? Well, you'd take 732, divide it by 2, and you'd get what? 3, you'd get 13 would be 6, we'd get 12, 366. So you could go 2 times 366. But now, is 12 a factor? So let's look at some of these other ones. Well, how do you know if 12 is a factor? Well, you just go, hey, let's go 732 divided by 12. If you have your calculator handy, I don't have one handy here, so I'm going to do it the old-fashioned way. So 8 is 72. Hey, 12 and 81. 12 works. How about 7? Is 7 a factor? So we take 732, divide it by 7, we get 1, 7 is 0, so we bring down the 3, doesn't work. So 32 by 7 is 4, and that's 28, and we're left with 4, which is my remainder, so 7 is not a factor. We use division to determine if it was a factor. So that's where polynomial division comes in. We can use this to determine whether it's a factor. Is when you divide it, do you get 0? Okay, that's good. We got synthetic division helps us divide these factors we want, but the big question is, what are the possibilities? What could be a factor of this polynomial? So we'll pull out a nice definition. We got the rational zero test. It says, and can read this through. You might want to pause it to get it quicker, or I'll have the gist. If you have this polynomial, and nth degree, any rational zero, that's a zero that could be written as a fraction of integers. So we're talking about real numbers. We're not talking about square roots. We're not talking about irrational numbers. We're not talking about imaginary numbers. We're not talking about anything too weird except integers and maybe fractions. You can do that by looking at this P over Q, where P is a factor of the constant term and Q is a factor of the leading coefficient. So that might sound confusing right now. Let's put that into practice. Let's look back at this other problem we're looking at already. So, let's clear off some room, blah, 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 blah. I don't like this drawing program as much. I don't have a really easy way to erase, big portions of the screen except using the old-fashioned way of grabbing an eraser, right? Okay, so we look at this. This problem is nice. The leading coefficient is 1. The factors of 1 are 1 and 1. So that's easy. Here we have 12. The factors of 12 are going to be 1 and 12, 2 and 6, 3 and 4. Now, we say, hey, but that's a negative 12. Well, either negative or positive, we can always put in plus or minus on each one of these. And then with that, our possible factors then, we could have, if it's plus 1, we could have x minus 1. We could have x plus 1. We could have x minus 2. We could have x plus 2. X minus 3. X plus 3. X minus 4. X plus 4. X minus 6. X plus 6. X minus 12. And x plus 12. Those are all the possible factors. Because these are all the possible zeros. Doesn't mean they are all factors. In fact, they can't. It's fourth degree. It can only have 4 factors. And it doesn't necessarily even mean any of those are factors at all. It just means if there are any factors that are rational numbers. If we have zeros that are rational numbers, it's going to be one of these, so a nice factor will be one of those. So those are the ones we want to test. Now this is where, at this point, it's just guess and check. We're going to go through and do a bunch of guessing and checking till we find ones that work. This is where synthetic division is really nice, because we might have to do a bunch of these. So we'll start off with 1, 2, negative 7, negative 20, negative 12. And I will start off with x minus 1. So I'll plug in, if it's x minus 1, that comes from a root of or a 0 of positive 1. So I'll go 1, 1, 3, 3, negative 4, negative 4. This is obviously not going to work. So x minus 1 is not a factor. So I just go through and do it again. So we'll try some different numbers in here. So we'll try negative 1. This factor of x plus 1. So we got 1, negative 1, 1, negative 1, negative 8, positive 8, negative 12, positive 12, 0. This is a factor. I have one factor of x minus 1. Now, here's the cool thing. I've at this point broken this down to x plus 1 times x cubed plus x squared minus 8x minus 12. Now, I don't have to keep trying to look for factors for this whole polynomial. I got this x plus 1 out. I can just work with this one here. Now let's try to find a factor out of here. So, but look, I already have this problem set up here, so I can just set up another synthetic division right underneath of there. So I will try, well, let's try the next one. Let's try x minus 2. So I got 1, 2, 3, 6, negative 2, negative 4, negative 16. Nope. So we will cross out that one. Let's try negative 2. 1, negative 2, negative 1, 2, negative 6, 12, 0. That gives me 0. That one's a factor. So now I've limited this down to, I have x plus 1, x plus 2. And now at this point, I could keep working and try to find factors for there, or I could say, hey, wait, I got x squared minus x minus 6. That's a quadratic. I can plug this into the quadratic formula, Or I can try to do one of these. Let's see. X squared is going to be giving me x and x. Negative 6. 1 and 3 is not, well, one of these is going to be plus, one's going to be minus. 1 and 3, 6 is not going to work, but 2 and 3, I have a negative 3, a positive 2. I got 2x. I got minus 3. No, that's not going to... 3x, yeah, that's going to work. Because that gives me a negative x. And so I have a factor of x plus 2 and an x minus 3. And now I'm factored. If I can get it down to a quadratic, I have other methods. Otherwise, I can keep on plugging in. But here's another thing. If I look at this, once I got it down to here, x squared minus x minus 6, I'm now looking at factors of 6, so I know that x, these two are out automatically because I can't get that to get 6. It has to be these. Also look, I could repeat a root. So just because you found one doesn't mean you should just stop. You can try again and say, well, does that one work again? Let's give you one for you to try. See if you can make sense out of this. See if you can work through one of these. Let's go x to the 4th, 6x to the 4th, plus, nope, I don't want to do that one. Let's be nicer to you here. Let's go x to the 4th plus 12x to the 3rd plus 50x squared plus 84x plus 45. And try to factor that. So first thing you want to know is find the possible factors. So pause this, see if you can find your possible zeros, possible real zeros. Look at factors of 45. I could be 1 and 45. 2 doesn't go in. I could go 3 and 15. And I can go 5 and 9. Again, all of these could be plus or they could be minus, even though this is just plus. Now, the fact that everything is plus in here makes me think I'm probably just going to have all my factors are going to be x plus. But that's still not a guarantee. Who knows? So now, pause this again, see if you can factor this. Okay, when I go through this, 1, 12, 50, 84, 45, I'm going to look and say, hey, to get 45, I got to have 5, 15, or 45. So I'm going to start with my 5s. I'm guessing, since everything's positive, positive looks good. So my first guess is going to say, let's just try with negative 5. See what that does. So I'll go 1, negative 5, 7, negative 35, 15, negative 75, 9, negative 45. Woohoo! Sometimes you can narrow things down. That doesn't always work. Okay, so now I'm down to 9. So I can cut out this one and this one. It's the 1s, the 3s, and the 9s. So it's 9, so I'm going to go for a 3. So let's try my next one. Let's try a negative 3. So I'll go 1, negative 3, 4, negative 12, 3, negative 9, 0. That, again, worked out nicely for me. Now I'm going to take a look at, say, I got a quadratic, x squared plus 4x plus 3. And that looks pretty nice to me, as 3 has to be 1 and 3. And if you add 1 plus 3 together, you get 4. So those are my other two. So I add the factor from here. That negative 5 gives me a factor of x plus 5. This negative 3 gives me a factor of x plus 3. And then from down here, I got that factor of x plus 1 and x plus 3. That's that process. It's a lot of synthetic division on here. I got lucky doing this one. Sometimes you get lucky, sometimes you don't. It's really a process. Factoring is always a process of guess and check. But that whole idea of this rational zero test is look for the factors of your constant term. Look for the factors of your leading term. We should do one like that here quick. So let me give you one more to do. We'll talk about the possible ones on this one. So let's clear one more off here. Now let's do these 6x to the fourth plus 23x to the third minus 14x squared minus 43x minus 12. So we look at the factors of 6, can give you 1 and 6, 2 and 3. The factors of 12 can give you 1 and 12, 2 and 6, 3 and 4. So your possible factors are going to be of the form one of these over one of those. So I could go 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. Then I can go to the next one. I can go 1 over 2, 2 over 2, 3 over 2, 4 over 2, 6 over 2, 12 over 2. But 2 over 2 is just 1. I have that one already. 4 over 2 is just 2. I have that one already. 6 over 2 is 3. 12 over 2 is 6. So this one only gave me 2 new ones. Then I'll go 1 over 6, 2 over 6, 3 over 6, so that's 1/2. 4 over 6. Oh, I know what I did wrong. Never mind. 6 over 6, that's 1. 12 over 6, that's 2. Let's do the thirds. I skipped that one. So I'll go 1 over 3 is the same as 2 over 6. 2 over 3 is the same as 4 over 6. 3 over 3 is the same as 1. 4 over 3, I don't have that one. 6 over 3 is 2, I got that one. And 12 over 3 is 4, I got that one. So my possible real ruts, I have 1, 2, 3, 4, 6, 12, 1/2, 3/2, 1/6, 1/3, 2/3, and 4/3. So that's what I can try. And again, all of those can be plus or minus. Now, I'm going to let you play with that if you want to try to work this out and figure this one out. This one might take a little while to do. I'll give you the answer so you can check and see if you got it right. But I'm already at 20 minutes, so I'm going to not work this one out for you. This one is going to be x plus 1 times x plus 4 times 3x plus 1 times 2x minus 3. Once you find these two, use the quadratics, or you can try to factor it. Or this could be x plus 1, x plus 4. 3x plus 1 is a factor, gives you an x of a negative 1/3. So this is x plus 1/3 times 3. And this one would give you your, would be 3/2. Oops, it's minus. With a factor of 2 here. So we could get a leading coefficient of 6 to match with that 6. And then you'll get those two fractions in there. Again, this is mainly about, how do you find which ones to try? I've talked too long. Enjoy.